Imagine a secret kept right here on Earth. The exact moment you whisper it, someone at the absolute edge of the universe instantly knows. To understand this, look at this diagram. We have two sealed boxes. Inside, we place two marbles, one red, one blue. We shuffle them and ship them to Earth and Mars. If you open the box on Earth and find red, you immediately know the Mars box holds blue. There's no mystery. The colors were fixed from the start. But in the quantum world, particles don't behave like solid marbles. Before you look at them, they exist in a fuzzy, undefined state. They are formless, shifting possibilities, neither red nor blue, until the exact second human observation forces them to pick a color. So what happens when you open that box on Earth? Did the simple act of you looking at your marble actually force the one sitting on Mars to instantly snap into a solid color? If looking at an object right in front of you can dictate the physical state of an object millions of miles away without any signal passing between them, our entire understanding of cause and effect falls apart. Imagine two coins spinning rapidly in midair, miles apart from one another. While they spin, they are a complete blur, neither heads nor tails. Then you reach out and slap one of the coins down onto a table. That action forces it to lock into a single state. Let's say it lands on heads. At the exact millisecond your hand stops the first coin, the second spinning coin, miles away, instantly drops to the table, landing perfectly on tails. How did the second coin know what the first one did? Are these objects communicating faster than the speed of light? Or is nature secretly rigging the outcome before the coins ever start spinning? The search for answers led physicists away from laboratory analogies and toward the light of distant galaxies. They used the random, unpredictable fluctuations from those specific stars to dictate exactly how they would measure a pair of tiny, entangled quantum particles inside an observatory right here on Earth. The settings for these measurements were chosen by starlight originating from opposite sides of the universe, billions of light years apart. Yet, when the Earth-bound particles were tested, they still mirrored each other's states instantaneously, even traveling at the absolute maximum speed allowed by physics, the speed of light. A signal would not have had enough time to cross the dark void between those two target galaxies to coordinate a result. Since a physical signal couldn't possibly travel fast enough to pass the message, there has to be an invisible, instantaneous thread tying these particles together. Albert Einstein felt absolute disgust toward this idea. He famously dismissed this instant connection as spooky action at a distance. In 1935, he partnered with Boris Podolsky and Nathan Rosen to publish what is now called the EPR Paradox. This paper was a theoretical weapon designed to prove that quantum mechanics was incomplete. Look at this diagram from their argument. Einstein proposed a hidden variable solution. He argued that particles A and B must carry a hidden script, that they agreed on a secret predetermined plan before they ever flew apart. This belief was rooted in the principle of locality. To Einstein, the universe had to be sensible. For one object to influence another, they either had to physically touch or they had to send a signal bound by the speed of light. The EPR paradox was his ultimate attempt to protect human logic. He was defending the universe's ultimate speed limit against what he viewed as mathematical magic. But in 1964, a physicist named John Bell published this paper. He formulated a mathematical theorem that could definitively test whether Einstein's hidden script actually existed. Physicists Clauser, Aspect, and Zeilinger applied Bell's mathematics to real-world tests. As the lower diagram illustrates, using random numbers to control filters proved no advance information could be shared. There are no hidden variables. Particles decide their state the moment they are measured. The EPR paradox failed to break quantum mechanics. Instead, it accidentally provided the framework to prove that impossible, instant connections are a real feature of our physical world. This leaves us with a staggering implication. The universe is not a giant ticking machine made of separate, isolated gears turning independently of one another. Beneath everything we observe and touch, the fabric of reality is entirely entangled. If two objects can remain a single system despite billions of miles, a void between them, then the physical gaps we see lose their meaning. This implies that distance, the very thing that keeps the universe separate, is less a physical wall and more of a persistent illusion. No matter how vast and lonely the night sky appears from down here, the universe has never actually learned